Yes, am I audible, Humaira?
Yes, ma'am.
All right. So let's start with the next chapter, that is chapter 4. This chapter is laws of motion. Now, before this part, when we did kinematics was all about just movement. The bodies were just moving. When we discussed kinematics, that is your motion in a straight line, motion in a plane, this was just all about the movement of the bodies. We never discussed why did the body move. In the first place, why was the body moving? If a car was moving at a certain speed, why was this car moving? We never discussed. So laws of motion basically talks about the causes, that why is the body moving. The answer to this is because of the forces. So now you will be introduced about the forces in your system. Before we have, there are certain laws that are given by Newton, so we have to discuss those. First term is the whole concept of inertia. Inertia basically means that it's a characteristic, it's a property, it's not a force that is applied, but it's just a characteristic. That means if I am there, if I'm sitting right now, my body has a tendency to remain seated. I'll get this tendency to remain seated until an external force is acted upon the body. Like if I have, let's say here, I put this pen. Now, till there is no external force applied, it will continue to stay in the state of its rest. It will not move at all. If you have thrown a ball and the ball is rolling on the ground, it's rolling on the ground. Till the time you don't stop it, it doesn't stop it by itself. So why does the ball come to rest? Because of the frictional force. So friction force and all we'll discuss in later. So inertia, it's the term. This term was introduced by Galileo. It's the inability of the body to change the state of rest or uniform motion. Means if the body is at rest, the body will continue to remain at rest. If the body is in movement, if the body is in motion, the body will continue to stay in motion. All these things we apply will be applied till the time any external force is acting. External force definitely will stop or change the inertia. Now, see, inertia is not the force which is resisting the body to move or not change. That ability of the body to not change its state, that characteristic is known as inertia. You call that characteristic, like a property of the body, as inertia. So inertia is what? It will be the inability of the body to change its state of rest or uniform motion. Or even direction. Three kinds of inertias are there that I'll tell you. So if I am at rest, not even let's talk about some non-living objects, because we at least have the muscular forces that can act external. So inertia, yes, this term was coined by Galileo. It's the inability of the body to change its state of rest or uniform motion by itself. It's the property of the body, not a force. Property, remember this, have this in your mind that it's a characteristic, property of a body. There's no force which is being applied. And inertia depends on the mass of the body. Means huge is the body, greater is the inertia in it. Means the best example you can understand is if you're standing in a bus, in a moving bus. So at least I don't know about your places in India. This happens a lot, bus traveling and all. So here, if you're if you're there standing in a bus and the bus is moving, so you are in a state of motion. As soon as the brakes are applied, or even in cars, this occur when you're sitting in a car. Then what happens whenever the brake is applied? Because your body was in the state of motion earlier, now as the brakes are applied, the body continues to stay in motion and you tend to move forward. That is what is meant by inertia. Because your body was in motion at the first time. Now your body is at rest, is coming to rest. So there's a change. So body is not able to adapt to this change. It remains seated and it remains in motion even after the vehicle has applied the brake. So that inability of the body to change its direction, that is known as inertia. So Newton gave his first law, which is known as the law of inertia. This is known as the law of inertia. This is known as the law of inertia. Now, what is this law of inertia basically? he introduced the concept of force. That okay, inertia is there. All the statements that we studied before this, they are valid. Body will maintain its inertia. Now, the term he applied was that unless external force is applied on the system. What did I tell you in the introduction? That laws of motion deals with the cause of motion. We had never used the term force before this. We never used the term. We just had velocity. Car has started to move. Okay, a body is moving with this speed. That's it. We never said a force is applied. That's why the body moved. So what happened before that? That mechanism is there in this chapter. That is your laws of motion. So body will maintain its inertia until an external force is applied in the system. And what is this external force? This we'll study in detail in the Newton's second law. So body will maintain its state unless external force is applied. This means, let's say a ball is rolling on the ground. Ball will continue to roll on the ground. It will continue to move. It will just move. It will move. It will keep on moving forever. Why does a ball stop when we throw it? Or if you have kicked a ball, it stops because there is no external force acting. So according to Newton only, ball should keep on moving. Reason is that there is an external force acting. That is the frictional force. So frictional force is a force that resists or opposes the motion. That's why the things that are moving come to at rest. So this is what is meant by Newton's first law. Body will maintain its inertia unless an external force is applied on the body. An external force can change the inertia of the body. Now, what can be the types of inertia? There are three major types of inertia. First is the inertia of rest. Inertia of rest means if, let's say, I have kept a box of, let's say, 3 kg on the surface, it will continue to stay at rest forever unless an external force comes in. If there's an external force, let's say somebody kicks this, it will move in the direction. Or if I lift it up, it will move. Or we throw this, or we push this, or some external force is acting, it will push. Till the time this external force is not acting, until it's acting, this will stay in the state of rest only. Now, second is inertia of motion. Inertia of motion means body tends to maintain the state of motion. Means the example that I gave you. If a ball is there and it is rolling on the ground, this ball is rolling on the ground. So it will never stop. It will only stop if the friction force comes, and this frictional force will be the external force in that system. Then only the ball will stop. And then you have inertia of direction. Let's say if a body is moving in a straight line, it will continue to move in a straight line until some external force acts and the direction is changed. Or even if a body is moving in a circular path, it will continue to move in the circular path until an external force acts tangentially and changes its direction. So that is what is the Newton's first law, which is known as the law of inertia. That is inability of the body to change its state of rest or uniform motion by itself. So write down this part, then we'll see momentum. That's a very important topic. I hope till here it's clear to all.
Yes, ma'am.
All right. Please write it. Done, class?
Yes, ma'am.
See, coming to the topic, momentum. Now, momentum means how much amount of motion is there in the body. You can understand, see, when you move out from a, when you jump out of a moving train or when you jump off a moving bus, so what happens? Your body tends to move a bit. You can't just jump and stand and be at rest. When the train is moving on the, when the bus is moving and you're jumping off it, then your body tends to take a few steps and then you stop. The reason is that the body has some amount of motion left inside it. So because of that motion, there is a movement covered by the body. So that amount of motion that is left in the body is known as momentum. And this is because there is the mass of the body which is existing, as well as because of movement, there is an associated velocity. So momentum is basically amount of motion in the body, and very easy. Momentum is represented with a P, and formula is mass into velocity. So I'll just put one more definition, that is product of mass and velocity. It's the product of mass and velocity. P is equal to mv. So P will be equal to mass into velocity. So what is P? P is basically the symbol for momentum. M is the mass of the body, while V is the velocity. So altogether, momentum is a vector quantity. Mass is scalar, velocity is vector. So momentum is a vector quantity. And whatever will be the direction of this velocity will be followed by the momentum. And what's the SI unit? See, mass is kg, velocity is meter per second. So this becomes kg meter per second. That's its SI unit. Like a very easy, simple example I'll give you. A body of mass 10 kg is moving with a speed, with a velocity of 5 meter per second. Calculate its momentum. Momentum will be mass into velocity. Mass is 10, velocity is 5, so momentum becomes 50 kg meter per second. And whatever will be the direction of velocity, same as that of velocity. This is the direction which is same as that of the velocity. Now, whenever the momentum changes, inertia also changes. Reason is that there is no external force acting on the body. So whenever the momentum changes, it changes the inertia. Because see, momentum is related to motion. So if the body is in moving, is in motion, or the body is at rest, momentum can bring a change. And the external force should not be equal to 0 in this case. It should be non-external, means some value will be there. That's why external force is acting. This is your external force. External force is acting in the system, and so you are getting momentum. So what is momentum? Again, a revision. Momentum is basically the amount of motion in the body. It's the product of mass and velocity. P is equal to mv. How much motion is there in your body? Like an example, I'll tell you. Recoiling of gun. When you have a gun and you shoot it with a gun, because there is so much of momentum in the gun tends to recoil backwards. That's why it is advised to hold the gun near the shoulder, because it doesn't recoil much, then you don't get your shoulders hurt. So momentum is basically amount of motion in the body. Direction will be exactly the same as that of velocity, vector quantity with the unit kg meter per second. If CGS unit is asked, you can use gram centimeter per second. Am I clear till here? Momentum is clear to all? Humaira, Mariam, Navia?
Yes, ma'am.
Mariam, Nabiha, you there?
Yes, miss.
All right. Okay, please write down this one, then we'll come to Newton's second law of motion. That is very important. Please write it. Okay, class, let's move forward. Newton's second law of motion. First law is completed, and momentum is very helpful in the second law as well. See, I told you in the first law that whenever the body's inertia is there, so its inertia will not change unless an external force acts on your system. Now, the Newton's second law of motion focuses on this external force, means calculation of the magnitude of this external force. So it's a relation to measure force. External force acting on the body is actually equal to the rate of change of momentum. Now, what is all this? Let me explain you. Whenever you have the meaning, whenever you have the term rate, it means a change with respect to time. Change with respect to time. So here it says this external force that we have been continuously referring, that external force acts in the system to disturb its inertia and change its states of inertia and all. So what exactly this external force is equal to the rate of change of momentum. Momentum divided by time. What is this external force? The Fx, this is the external force. dp over dt. This is the rate of change of momentum. And they both are exactly equal to each other. The external forces, how the momentum is changing with respect to time. From 0 to 1 seconds, then 0 to 1 seconds, 1 to 2 seconds, then 2 to 3 seconds, like this, the momentum is changing. So that change in momentum divided by time is what we call. Now, I have been using the term external force a lot. What exactly is the meaning of the term external force? Like, when do we use external forces there in your system? For that, you have to understand a simple concept of internal and external forces. What is the meaning of it? Let's say we have sun and earth is present. Okay, sun is there and earth is present. Now, sun and earth are separated by a distance, and the earth tends to cover this whole rotation and revolution. Rotation also, revolution also. Now, I am focusing something on sun and the earth, that's it. So system means, whenever we use the term system, system means class, the part of the universe which is under observation. This is under observation. Part of the universe which is under observation. So like in this case, it will be sun plus the earth. The sun plus the earth is here, is your system. That's it. Now, anything apart from the sun and the earth, that will be termed as the surrounding. Anything that is there apart from the earth and the sun, this is termed as surrounding. So basically, we say that the system plus surrounding they make up the entire universe. Any system means that the part which is under your observation, it is under your study. Like right now, I'm focusing on the sun and earth. That's it. Apart from the sun and earth, anything that is present in the universe will act as a surrounding. Now, if the force acts between my system, within my system, let's say, see, sun is there, earth is there. So between them, a gravitational force will act. Between earth and sun, a gravitational force will act. So this gravitational force, because it is acting within my system, this is known as the internal force. And if any force comes from outside, any force from anywhere that comes from outside, that is termed as the external force. Means whatever your system is there, this can be as simple as, let's say, the pen in my hand, that's it. If this is my system, the pen is my system, then anything that acts beyond gravity or anything that is acting apart from the pen means that is coming from the surrounding. External forces come from surrounding. These are the forces coming from the surrounding, while internal forces are the forces coming within the system. So this is what is meant by, when we use the term external forces, zero internal forces, this is what is meant by this. internal force and the external force. If your net force is zero, internal as well as external, we use the term isolated system. Tell me, class, this whole theory is clear to you?
Ma'am, how the net force is 0?
No, I'm saying if the net force is zero anywhere in your system, anytime, wherever the net force is zero, let's say upward force is balancing the downward force, not in this case, definitely not in this case. But if you see anywhere that external force is zero, then you can call that system isolated because you will see numericals where the term isolated will be mentioned. So isolated system means that the net force is zero. Let's say upward force is balancing the downward force, rightward force is balancing the leftward force. In that case, so you can call your system whatever you have chosen. This can be very simple. If I have a glass of water put on a table, now the gravitational force is acting within my system. Gravitational force is acting on the glass of water. That will be my internal force. But if something comes from outside and pushes the glass and the glass is thrown, so we say that is the external force. Is the term internal and external clear? I have gone to the depth of it so that because this term external and internal will often be used, so you should be able to get it. Is it clear?
Yes, ma'am.
Yes, ma'am.
All right. So copy till here, then few more things about momentum I'll discuss. Yes, done.
Yes, ma'am.
Okay, see, now if we have a very small derivation that was there in your ninth class as well. Force is equal to dp over dt. Class, what's the formula of momentum that you have written? Tell me, what is the formula of momentum?
Mass into velocity.
Mass into velocity. Yes, Sumaira, very good. So mass into velocity. So if I put this value here, I'll get F is equal to d mv over dt. Now see, if mass is constant, then mass can be taken out and dv over dt can be left. Can any one of you tell me what is dv over dt? We have done this in the chapter.
Acceleration.
Acceleration. Very good, Omera. This is acceleration. So basically, the formula that we get is F is equal to ma. This is a very important formula where is the force, m is the mass of the body. This is the mass of the body, and a is the acceleration of the body. A is the acceleration of the body. F is equal to ma. You have done it in your lower classes as well. So this is the same formula and a very, very important formula. You have to use it throughout. Even in class 12, it can come. SI unit of force is Newton, capital N, and CGS unit is dyne. It's a vector quantity. So 1 Newton is 10 to the power 7 dyne. Sorry, 10 to the power. So numericals, we'll see later. First, you write down this much. See, this question says the body starts from rest and attains a velocity of 10 meter per second in 5 seconds. Mass of the body is given as 5 kg and it says calculate the force. See, force is equal to mass into acceleration. Now, force is missing here and mass is given as 5 kg. Class, if we get acceleration somehow, then we will be able to calculate the value of the force as well. Acceleration is directly not given in the question. It says body starts from rest. So initial velocity is 0, final velocity is 10 meter per second, and time is 5 seconds. And we have to get the acceleration. Let's look at this data. U is given, V is given, T is given. Which equation should be used to calculate acceleration? Three equations we have done.
V equals U plus AT.
Very good. V is equal to U plus AT. From here, we'll use V is equal to U plus AT. So this is 10 is equal to, this is 0, A into 5. Acceleration is 2 meter per second square. Now force will be mass into acceleration, 5 into 2. That is equal to 10 Newton. Right, this one more question we'll practice based on this. See, this says a scooterist moving with a speed of 36 kilometer per hour sees a child standing in the middle of a road. This is a question from your NCRT. So he applies the brakes and brings the scooter to rest in 5 seconds in order to save the time. And you have to calculate the retarding force that acts. If the mass of the vehicle plus the driver combined is 300 kg, car plus the driver means the total mass that is given to you is 300 kg. Now, he applies brake. See, scooterist is moving with a speed of 36 kilometer per hour. The initial velocity is 6 kilometer per hour. Yes, Nabiha, how do we convert kilometer per hour into meter per second? If I have this,
We multiply it by 5 by 18.
very good, correct. So we multiply it with 5 by 18. So this will be double of it. Yes. So that is 10 meter per second. So that is the initial speed with which it is moving. Now, time, it says final velocity is 0. Final velocity in this case is 0 and the time is given as 5 seconds. So I think the similar equation we have to use to find the equation v is equal to u plus at. V is 0, u is 10 plus acceleration we don't know, time is 5. So see, in this case acceleration will come out to be minus 2 meter per second square. Now, I have already discussed this negative sign with you when we were discussing the uniform acceleration questions. I told you negative acceleration is a term for retardation. When the velocity decreases or we have the negative acceleration in the system. For that, the negative sign is used. Okay, now you have, anyway, you have to calculate the average resistive force, means the opposing force. So it will be negative. Mass into the acceleration. Mass is 300, acceleration is minus 2. So force is equal to minus 600 Newton. Now what is this minus sign signifying? Minus sign is basically signifying that this is a resistive force. Resistive force means it's the opposing force. It opposes the motion. So this was one more question. Now the third law we'll complete so that Newton's laws are completed into today's task. We'll be able to complete that. Okay, please start writing from here.
So, ma'am, the resistance force will be the frictional force.
No, not necessary. There are different kinds of forces acting. So whatever is the resultant of all those, that will be there. We'll study how the different forces are acting on the body. It's never always friction force. What if some other forces are also combining with friction? So that's why a common term resistive force is given here rather than friction. Okay.
Okay.
Okay, coming to the Newton's third law of motion, this basically talks about the action reaction. This is known as the action reaction law. It says to every action, there is an equal and opposite reaction. Now, what's the action? Suppose body A exerts a force on body B. This is the force due to A. So, a similar equal force, but in the opposite direction, will be exerted by the body B on this A. Since they are acting on different bodies, you cannot cancel them. If I separate them, this will be my block A with this FB force, while this will be the block B with this FA force. So see, they are not getting cancelled because the forces are acting on two different objects. For forces to get cancelled, they should act on the same object. So forces do not get cancelled. But because their magnitudes are equal, you can say FA is equal to minus of FP. This is what the Newton's third law of motion says. To every action, there is an equal and opposite reaction. And action and reaction are instantaneous and act on different bodies. That's why they do not cancel each other. Now, class, in your NCERT, there's there's an example given. Forces that act while we walk. This is based on the Newton's third law, and this is an application-based question that comes in your exam. See, let's say this is the ground, and the person has striked his heel. Okay, the person has striked his heel over here while moving. So what happens when you strike your heel? You exert a force on the ground. This is the force on the ground. So what happens? According to Newton's third law, action, a reaction. So ground also exerts a reaction force on the person. Reaction force by the ground. Ground also exerts a reaction force. Let's say this makes an angle theta with the person. So downwards, you will have the gravitational force acting. Gravity will be occurring. This will be the force of gravitation. So gravitational force will be acting over here. And when you resolve the components, this will be, see, theta is made with this. What did we discuss? Whenever theta is made with the axis, that receives cos component and the other one receives sine component. So you have r sine theta and r cos theta. So basically what happens here is this r cos theta balances mg. Okay. Or let's do one thing. Let's change the angle. Let's make it with respect to the ground. That whenever you have any angle given with respect to the ground, you can resolve. In this manner, this becomes r cos theta and this becomes r sine theta. So look, your r sine theta basically balances the weight. R sine theta balances the gravitational force, balances the gravitational force. Why? Because see, above your head, our sine theta is acting. Below, mg is acting. So they'll balance each other. That's why you do not move along the y-axis because both of them are balancing each other. But what about the x-axis? Along x-axis, r cos theta provides you a force on the backward side. So your body, in order to compensate that, moves forward. R cos theta is responsible for forward propulsion. Means the body moves forward. So that is one very classical example of Newton's third law which comes in the exam. Action on the ground, this is your action on the ground, this is the reaction by the floor. Action, reaction. So Newton's third law says this. So Newton's laws are over. Are you clear, everybody?
Yes, ma'am.
Others? Nabiha, clear to you? Mariam?
Yes, miss.
Tahura, what about you? Nabiha, is it fine?
Yeah, ma'am, understood.
Okay, all right, Kahura and Nabia. Please copy down this part that completes with Newton's laws. Now, impulse and momentum is there, and that's the next topic that we'll discuss in the next class. Please write it till here.
Ma'am, 1 minute, can you scroll a little bit up? Then
Plus, if you have completed looking in the next week I'll continue from impulse and momentum. Okay, this completes with Newton's laws of motion. We'll start with impulse in the next class. Okay, please do the assignments. Those students who haven't done, we'll discuss the assignments of the previous chapters in the next class. Okay.